Again, one of the uses of learning these tools of math is that we're able to understand some different phenomena that we're able to recognize in the real world. So for example, the average height or the average height of somebody growing on up models roughly a square root function where their height changes, but as the older you get, the rate of growth starts to slow. So it models roughly a square root function. And if we're able to recognize that, then we're able to go ahead and start to make some guesses of what happens at particular ranges in time to heights. And we're able to develop an expression that kind of models the average rate and change between any 2 points. That expression is this function where we have some a plus h, some age, plus a couple of years, plus some additional time. We subtract it from its current age and divide it by its height. So that model starts to help give us the average rate of change. Remember that? We've seen that before. And the average rate of change is the slope. And what we want to do is we want to find the slope at any specific point in time. And that's the birth and essence of what calculus will teach us to do. So for our purposes right now, we're just building the skills to help us make other subjects like calculus understandable. So let's look at this expression that we were given. And that expression evaluated with this function becomes the square root of a plus h minus the square root of a over h. Now, in this particular case, to use it, our friends are going to want us to be able to rationalize the numerator. And when we're able to do that, that's going to help us solve their problems. But that's their problems. They're coming to us right now to help us just simply learn how to rationalize the numerator. Wait a minute, Willie. You said we don't do that. We always rationalize the denominator to make something simplified. Yes, most of the times we do. But you're going to find out our friends in calculus once in a while may need us to do it the other way around. So when they ask, let's be ready. How do we rationalize that expression's numerator? Well, first, let's just write that expression down. So it's a plus h, the square root of a plus h minus the square root of a all over an h. What do? We try to discover what its conjugate is to help us build a clever version of 1. Its conjugate is a plus h plus the square root of a all over the same thing, because it has to be equivalent to 1. All right, there's my clever version of 1. It was formed by discovering what the conjugate is of my two-termed term. Multiply that on out. Which one do you want to do? Numerator or denominator? Well, they're both roughly the same. So the numerator, if we recognize this, it's first times first minus last times last. So the square root of a plus h times the square root of the square root of a plus h times the square root of a plus h is just an a plus an h. Minus the square root of a times the square root of a, well, that's just an a. Sorry, this is an h. I keep writing b's. That's an h, Willie. All right, the denominator, that becomes an h times all of that, a plus h plus the square root of a. Can we simplify that? Yeah, we can. I have an a minus an a on the top, so that just becomes an h divided by my denominator. There's nothing there to do, nothing to see, folks. And it looks like there's one last thing I can do. It looks like there's a factor of an h on the top that matches with a factor of h on the bottom. So I can cancel or factor those out. I'm left with a 1 with a root a plus h plus a root a. And now we're able to develop an expression that's going to help us determine at an instantaneous moment what we expect somebody's rate of change in their height to be. So that was kind of a bit of an exit ticket for this entire section.